Very good morning to everybody. My name is Francois van Pittius, and I will be your host for today. Subject of discussion today will be the PMD laser technology. Of course, this is a webinar. Of course, we have some rules that we need to follow. Please note that this webinar is being recorded. We will also make it available for you to share afterwards. The webinar is set up in such a way to ensure that the presenter can present without any distractions. Thus, you will not be able to see other attendees or their questions, and of course, you'll be muted. I encourage you to use the chat to post all your questions. I will capture all these questions during the presentation, and we will have an open discussion with the presenter at the end of the presentation. On our website, you can access all the webcast recordings, questions and answer documentation, and the presentations in PDF format. The one for today will become available a bit later. I would like to welcome our presenter for today, Denzel Hewitt. Denzel, over to you.
Thank you very much, Francois. Good morning, everybody. Hope everybody is well. It'll be a very informal discussion. A lot of the content you might already know. Chatting to your local sales engineers, you might even have a lot of the sensors in your plant already. But some of the stuff I hope is going to be new to you, and you'll find applications for it, or you'll be able to solve certain applications in your plant that you haven't been able to do in the past. Like Francois said, the topic of today is the PMD laser technology for accurate position sensing, available from IFM. You probably do have a lot of these sensors in your plants already, but there are some new ones. Firstly, a little bit about myself. My name is Denzel Hewitt. I work out of the Port Elizabeth office. I've been selling IFM equipment now for in my 19th year. I am predominantly out of the motor industry. I used to work at Firestone before that, and Volkswagen South Africa. So I've probably got about 25 years experience in the automotive industry, and I'd like to think I've solved a lot of applications along the way with IFM. So hopefully, yeah, I can help you guys out. My business card is all the way up at the end again. If you want to contact me directly, that's fine, or you can contact your local sales engineer to arrange a demo for any of these sensors that you might see today. Look at the agenda. We'll be covering what is PMD technology. If it's new to you or you don't know the term, we'll cover the different PMD technology sensors in the IFM range. We'll also go over something new that you probably haven't seen before, some uses and examples and applications that might be in your plant. And like Francois said, we'll cover the Q&A session right at the end. Okay, let's get started. Traditionally, what have we used with lasers to measure? How have we done it? Well, we've used a sensor that uses the triangulation method. Now, the way this works is, if you look at the picture on the right, and yeah, you've got a semiconductor laser, transmits a beam, reflects off the target, and it hits this emitter plate. And wherever it hits the emitter plate, it'll determine how far the target is away using triangulation method. Now, there are very good sensors. IFM has got them in our range as well, but there are some factors that you need to consider when using triangulation method sensors to either do switch points or analog sensing values. Okay, firstly, they are very accurate, but that accuracy comes with a bit of a cost or price. They are affected by different colors. So if you've got different color targets, you have to take that into consideration when using the sensor. It does affect the sensing value. Obviously, black targets absorb more light, lighter targets emit more light, and they can affect the sensing value. They can be affected by shiny and matte surfaces. Same thing, some absorb more light, some give off more light. They're affected by ambient lighting conditions. So in a factory, you've got roller shutter doors, day shift, night shift, skylights in the ceiling that can affect the value, especially on metal surfaces, stainless steel, that type of thing. The limited working range. So most triangulated sensor method, because this emitter plate can only be so long inside the sensor, they're normally limited, they'll come out in range, say 80 to 120 millimeters. So you can mount the sensor further back, but they are only limited in that range. So even a sensor that maybe says it can be mounted 1 meter away from the part will only have 200 mil range, or a working range, where it can actually pick up that value. They are very expensive, especially when it comes to the longer range sensors. You're talking tens of thousands of rands for a long-range, high-accuracy laser, triangulation method laser. And the most important point when using triangulation method lasers is they have to be accurate, they have to be mounted perpendicular to the part. If they are not, they either become inaccurate or they do not pick up the part at all. So you have to use that. You have to consider that when installing a triangulation method sensor to pick up a plant or do to pick up a part or do measuring with. Okay, PMD technology. What is PMD technology? Well, PMD stands for photonic mixer device, and it is more commonly known as TOF or time of flight. The way this works is the sensor transmits a modulated waveform which bounces off the target, gets transmitted back to the sensor, and these two peak-to-peak waveforms are measured and the distance away from the target can be calculated. So it is a really easy way of doing things. It's a relatively cheap way of doing things or inexpensive way of doing things. And there are a number of advantages, which I'm sure you'll be able to use in your plant. Firstly, the sensor doesn't have to be mounted perpendicular to the target. They can be mounted at acute or obtuse angles. So if difficult mounting applications in a fixture, welding, assembly fixtures, where there's an operator working with his hands, or a robot or manipulator working over the top, you can mount them off at the sides and they can pick up these targets part in place at angles. It doesn't have to be 90 degrees to the part. They're mostly color independent. So dark or light parts will be picked up at the same distance. They're not affected by external light. So day shift, night shift, the sensors won't be affected if shiny parts have got a lot of reflection off them. They've got reliable background suppression. So these sensors can be set up to say switch at 1 meter, switch at 300 millimeters, and anything beyond that will be ignored. They also have a visible red light spot. So for easy installation, so if you want to pick up a small washer or a fastener, you can do that from a long way away. You're not guessing as to what target you're seeing. Looking at the range, the O1D100 range is probably one of the most popular photoelectric sensors. It's been in the range for a long time. If you do buy from IFM, you've probably seen them, or the sales engineer at least come around and demoed them for you. These sensors are meant for bulk measuring or up to long distances, up to 18 meters without a reflector. They can be 100 meters with a reflector. These are often used for overhead gantries, cranes, anti-collision. They have digital and analog outputs. So the sensor is available with 4 to 20 and 0 to 10 volt on the sensor itself, plus a digital output, or you can use 2 digital outputs. These digital outputs can be set for a hysteresis or a window function, normally open or normally closed. Full metal housing. They are, if you look at the screws on the front here, they are female screws. You get floating glass lens covers that can protect the lens. So for instance, in a welding environment or a place where the operator could perhaps damage the lens with when he's actually working on the machine or the fixture, you get a glass cover that goes at the front. If the lens does get damaged, you screw it off, put on a new one, and you carry on as usual. The lens cover doesn't affect the sensing distance at all or the accuracy. There are also plastic lens covers. So for the food industry, where no glass lens sensors are allowed, there's a plastic lens cover that will cover the glass that if it does get damaged, no glass will end up in the product. Very good application for these is loop control. On a conveyor system where you've got a push-pull conveyor with a loop in between, you can mount the sensor from the top, picking up the loop. It'll give you your analog outputs or your digital top and bottom switch points, and you can speed up or slow down the conveyors accordingly. You've also got a special model for black targets, the rubber industry, tire, matte black surfaces. Moving on, we've got the O5D and the ORD range. These are for distance up to 2 meters. These are purely digital, normally open and normally closed. You get the mechanical on these M30 ones. There's the mechanical dial setting to set the switch point. And on the rectangular plastic bodied ones, they are on and off, and you can set the distance, and you actually got a little display on the top to display the distance that you're away from your target. These are in 1 centimeter increments. The M30 sensor, or the conventional, the M30 is 316 stainless steel with an IP69K rating. This M30 over here, without the dials, can be set. The set point can be set by IO-Link non-recorded device, the software available from IFM, and it is potted. So for instance, high vibration applications, like press applications for part in place, moving through a press, these are ideal. A sensor that is not potted on a press application will normally get damaged quite quickly because it just cannot handle that continuous pounding and vibration. All these sensors have got a variety of mounting options. So if you want to mount them on conveyor, we've got rod type manipulator, we've got high accuracy brackets that you can shine these down to either a standard conveyor line, a protective bracket to wrap around to actually prevent it being damaged, being stood on a conveyor, or for more high accuracy applications. Okay, the new range, the OGD5, long range and precision. Why were these created? Well, these were created, IFM didn't have a high accuracy laser using the PMD technology. We've always had more on bulk detection and 1 centimeter type increments being our most accurate. These are now down to 1 millimeter accuracy. So they are new to us. They also have the M18 fixing housing, which we haven't had in the past, which is probably the most popular housing in photoelectrics today. The OGD precision is 300 mils away, and the long range one can do up to 1.5 meters. So, but in 1 millimeter increments. The accuracy of the OGD-Q precision is in the same league as a laser that uses the triangulation method, but a fraction of the cost. And it also has a longer range. It's a lot more robust, being a full metal housing, reliable to object detection, not color dependent, and it has reliable background suppression. Yeah, 1.5 meter range on the long range one. Okay, to summarize then, the compact design, a lot smaller than our other PMD technology sensors, M18 thread in the front, the side mounting holes, up to 1.5 meter or 300 millimeter for precision, and independent of color. That's very important. Independent, normally open and normally closed outputs, also available with a window function and hysteresis. You can be set up via the 3 push buttons at the back. You can actually see the visible display on the side, or you can actually program the sensor via iLink or connect it up to an iLink master. The sensor has class 1 laser protection, so you don't have to worry about class 2. A lot of factories don't like class 2 lasers in their factory. Class 1 can be used in any application. It doesn't have to have any special controls or areas where people aren't allowed to access. Class 1 is perfectly acceptable in all applications. Yeah, and the housing is 316 stainless steel as well. Very good for small part detection, 1 millimeter spot at 150 mils away. In accuracy, so it's very, very easy to set up. What are the sort of applications you'd use the long range or the precision range? Well, the precision range, automotive industry, robotics, parts in place, like I said, picking up small washers or nuts, fasteners, handling technology, assembly fixtures. The long range may be more conveying, part in place from a distance, larger objects you need to detect, welding fixtures, parts in a fixture that where, like I said, where there are robot applicators or welding equipment working, operators loading parts. You can mount them off to the sides. It doesn't have to be perpendicular to the part, and it'll still pick up the object reliably. Okay, something new, the OGD 582 reflectivity. You might want to make note of that part number, and you can ask your sales engineer to come and show you if you want to. It has a 1.5 meter range, and you get 2 values back from the sensor. You get the distance that it measures, plus you get the reflectivity of that object on a scale of 0 to 900. So you can set those values independently. So you can set a switch point at 1 meter, and an object has to have a certain reflectivity of a certain value, and you can set up a bandwidth to detect that certain object. That can be the value itself of the distance and the reflectivity can be transmitted by an iLink cable, to an iLink master back to your PLC. And it can also differentiate between gloss and matte objects of the same color. So for instance, if you've got a matte black plate and a gloss black plate, for instance, you can actually detect not only is the part there, but which part you're actually using. So for instance, if you look at this picture on the right here, you'll see obviously all colors have different reflectivity values. The only thing that you need to keep in mind is if you've got an object that is mounted perpendicular to the sensor, the reflectivity will be at a certain value. But if you've got a lighter part, but it is at a slight angle, the reflectivity values actually might be the same. So you have to compare them at the same angles. Otherwise, the reflectivity value that you'll get back might be inaccurate. Please keep in mind this isn't a color sensor, but you can use it to detect certain colors as long as the angle to the part remains the same. So you can get the distance, is the part there or not, part in place, and you can also do reflectivity values back, and you can detect what color it is, but it's not a color sensor, but you can do it from further away. Color sensors traditionally have to be mounted very close, 15, 20 mils away for color detection of 1 or 2 or maybe sometimes 3 colors, and they are often damaged by the parts coming past. How are these connected? Well, you can connect it via an M12 connector, standard proxy cable, or you can also use it connected up to one of our iLink masters if you actually want the values coming back to your PLC. And they are Ethernet, Profinet, Modbus, or EtherCAT. So any PLC you're using in your factory, you'll be able to read those values back. But like I say, from the sensor itself, you can still get your two digital values, normally open or normally closed. Okay, let's look at some uses. Because the sensor is very accurate and you can use it at different angles, it doesn't have to be mounted perpendicular, you can pick up shiny objects that are at an angle. So for instance, parts coming down a conveyor, they've got an orientation, it'll actually pick up if the bearing or whatever you want to detect is mounted the wrong way around. Very simple application, a traditional sensor probably wouldn't be able to pick that up. Conveyor lines, the long range OGD, a lot of conveyor lines, either the reflectors break off, they get stood on, people walking over the conveyors, the reflector gets dirty, or the package itself that's coming past. If you've got a retroreflective sensor, has perhaps some shiny material, sometimes retroreflective sensors switch incorrectly. Or if you're running a normal diffuse sensor, obviously they have to be mounted perpendicular to where the boxes are flowing on the conveyor. The boxes are sometimes different colors. You've got gray boxes, blue boxes, white boxes, or if you've got text, you set the sensor up for a light color box, all of a sudden you get a box come past and it's got some text on, which is dark color, the sensors will switch incorrectly. OGD laser, mounted at an angle, 45 degrees, it can cover a long area of your conveyor line, and it doesn't matter what orientation the box is in. The color can change, the angle can change, it can be round, square, you name it, it'll pick it up reliably. Interesting application, you've got perhaps a car plant or where you're using different kinds of materials, black leather, matte black, gray, brown. As long as you're picking up the object at the same angle, you can use part in place from the distance, so you know there's a part there, and you can actually determine what material, for instance, the seat, whatever you've got, is actually. So for instance, in the traditional method of picking up those kind of things, you might have had to have a few different sensors to pick them up, but because you're getting the actual distance back, not just a part in place and the reflectivity, you can actually determine what object is there. Okay, let's look at some examples. So yeah, I've got 2 fasteners on my desk. On the far left, you'll see I've got a black fastener and the reflectivity is 5. Then I've got a nickel-plated brass fastener, and the reflectivity is 167 on a scale of 0 to 900. But you can see when I read the value back of the actual distance away, they are very, very close. That's 17.5 centimeters and 17.4 centimeters. So I can see that there is a fastener in place, that's fine, but the reflectivity value will tell me that I've either got the wrong or the right fastener installed. Can be used for thread detection. Now, traditionally, we've used our pixel counters, our vision systems to do thread detection, which works very, very well. I've got a lot of them installed. The problem is that normally you have to mount them quite close. This can be mounted further away. So for instance, if you look at the special sensor I've got mounted on my desk, I've got it on the smooth surface in the first picture, and you can see the reflectivity value is 5. If I look at the second picture, I'm now picking up on the threaded section, the same distance away, my reflectivity changes to 145. And that is because I'm now picking up the threads which are at a more perpendicular angle to the actual sensor. So the reflectivity value that I'm getting from the surface of the object is much greater. So I can actually detect if their threads are there or not. This often happens in where they're installing sockets or something onto a car part or any part, and sometimes those sockets are not tapped or threaded. And the part goes all the way down the line until there needs to be a screw or something placed in there, and the part gets scrapped because it's already been welded. So that's a very good application to solve when it comes to reducing scrap. Weld seam detection. This is normally quite a problematic issue in plants. You've got an exhaust system or a pipe that's got a weld seam on it. You can see that I'm picking up 102 on the reflectivity value. There is a part in place firstly, and I'm picking up 102 on the reflection. When I pick up on the weld seam, it's obviously very dark. The reflectivity changes to 18. The only problem you've got to keep in mind with an application like this is this can or the pipe can have a lot of dark marks on it, either dirt or clamping marks where it's been gripped by a manipulator. So what I suggest in an application like this is have 2 or 3 sensors mounted in series, looking down the weld seam, and all 3 or 2 at least have to be on simultaneously. Because if you just use one, as sort of this rotates, it could pick up any other values, and the value could think that it's the weld seam. So just keep that in mind if you are interested in an application like this. Pipe sizing, it can pick up, obviously, because you can get that value. If you don't want to use the digital and you want the actual analog value from the sensor, the actual size of the pipe, you can read that from the sensor. What's traditionally caused problems with sensors picking up pipes like this is they're normally covered in cutting fluids or oils, and the reflectivity does change. So then a traditional on or off method sensor would not pick it up reliably. It'll flash on or off, or when it hits a different surface, you might set it up on a shiny part and then it'll hit a matte part and the sensor will actually turn off. With a PMD laser sensor, you largely do away with that type of problem. Food processing plants, where the packages often changes, they're matte, they're glossy, they see-through, they're different colors, there's a lot of text on them. So you set up in one application, all of a sudden you're running a different product and the sensor doesn't work again. This time of flight, it's purely working off this, the distance away from the package. It'll pick it up reliably. Also, a good thing to mention is the sensor lens is plastic in this sensor, so you don't have to have any lens covers or protection on the front to worry about in the food industry. Crate detection, you can see the sensor is mounted over here. There is actually a vision system checking over the top of the bottle to make sure none of the bottles are sticking out. But it can actually detect the difference between the brown and the light green, and you can actually send off those crates to a different conveyor. So it is relatively high speed, not super high speed, but it can actually detect the color and it'll divert the crates to a different line. Thanks. Hopefully I've piqued some interest in maybe some applications that I've shown. And you can think of some applications in your plants. You can either contact me, myself, or your local sales engineer. Yeah, Francois, have we got any questions there?
Yes, Denzel, thanks. It was a great presentation, and I'm sure our attendees found this information very informative, of course. Yeah. Before I get to the questions, I just want to mention to you guys that if we do not address your question on this platform, please be assured that it will be addressed on our website and will become available in a couple of days for you to see the answers. Let's have a look at what we received. Some interesting ones here, Denzel, most definitely. Firstly, is there an analog version for distance measurement on the OGD 582?
No. The OGD 582 has only got 2 digital outputs, which can be normally closed. But if you use an iLink master, you can get those measured values back to your PLC on the up to the 1.5 meters or the 0 to 900 reflectivity scale. So there is a way of getting those back to your PLC either via Profinet, Ethernet, Modbus, or EtherCAT.
Excellent, thanks for that. Another one that we have is about the reflectivity. The question is whether it's only digital on and off.
Yes, via the sensor, once again, it is digital on or off, but you can say set a window. So for instance, if your reflectivity values, you don't want to set a switch point, you can actually set a band function. So from 100 to 200, anything in between there, it'll turn on or off. But if you want that value back, once again, you'll have to use the iLink. It is the way the automation industry is moving at the moment.
Excellent. Thanks for clarifying that one. Nice, interesting one here for you. Can one detect if the lens is dirty? And can you get a maintenance trigger from the device?
Yes. An interesting way of doing that is because you're getting two values from the sensor. You'll know that, for instance, when your switch point is, say, set at 1 meter, and you've got no part in place. For instance, there's no part that you want to detect, and the sensor is, for instance, sensing 1.5 meters. If your reflectivity value changes, or you seeing a change in your reflectivity value with no part in place, you'll know that the sensor lens is actually becoming dirty, and you'll need to take action and go and have it cleaned.
Well, that's excellent. It's a nice feature. Yeah, definitely simplifies the maintenance process instead of sending a guy out there every day to go and wipe a lens.
Definitely.
Yeah, great stuff. Thank you for that, Denzel. We're going to go over to the next platform, being social media for us. Where are we covered? So on the social media platforms, guys, you can see that we are on YouTube, Facebook, LinkedIn, and so forth. So we have quite a vast coverage. On the YouTube platform, you'll find a lot of demonstration videos, not just on the PMD technology, also on various other equipment that we do have available. So please go and have a look there on the YouTube platform and see if you have any applications, your solution might just be there for you. The rest of the platforms on the screen would be for marketing. On our website link on the screen currently, you'll be able to find the webinar schedule, the future ones and existing ones that's been dealt with in the past, the recordings, as I've mentioned earlier, the Q&A phases, all of that will be available there for you to have a look at. So yeah, thank you guys for attending. We appreciate your time. We're looking forward to seeing you again in our next webinars, and I wish you a very good day. Denzel's business card will remain on the screen for a couple of minutes after the session for you to take note of it. Goodbye.